Hello again. Today I would like to go through some word problems involving quadratics. This is going to be around a grade 10 to grade 11 math level. It's going to really depend on how advanced your class is. But the core idea with this video is to give you some examples of when quadratics can actually be useful in real life scenarios. Because a very common frustration that my students have is they'll learn things in math class, but they're not really sure when they would ever use this in real life or when it would ever really be useful. So let's get right to it. Question number 1 says, Taylor Swift is performing in town today. During a concert, she typically sells 100 t-shirts for $20 each. Her management knows that for every $1 decrease in price, she can sell 10 more shirts per concert. What is the maximum amount of money that Taylor can make? And how much should she charge for a shirt if she only wants to make $2,000? So, we have a maximum revenue question here, and we're given a relationship between the number of t-shirts we sell and the price they're sold for. Now, $20 a t-shirt for Taylor Swift is probably a little unrealistic. That seems kind of cheap, but let's go with it. So immediately, I need to think of how to represent these values in a quadratic. So if I want to think of how much money Taylor Swift is making, I need to think of the number of shirts she's selling, and I would multiply that by the price of each t-shirt. And what I'm going to do to help me out here is I'm going to represent a variable n, and I'm going to state that this variable represents the number of price changes. Right? So if I decrease the price of a shirt once, that would be a decrease of $1. Twice, $2, etc. So how could I represent the number of shirts sold using the variable n? So I know I start with selling 100, and for every change in price, I'm going to sell 10 more. So that's how I would do that, 100 plus 10n. And we're going to multiply that by the price of each shirt. So we're starting at a base price of 20 bucks. And each price change will decrease that price by $1. So you can see here, I actually have a quadratic in factored form, and that will be very useful for me. So if I take each individual value here, value meaning number of shirts or price, and I set each one to 0, I can actually solve for the zeros in this quadratic. So let's start with this one here. We want to isolate for n, so I'm going to move the 100 over the equal sign, and that's going to turn into negative 100. Then I'm going to divide the 10 out, and we see that n equals negative 10. That's one of our zeros. For our second one, I'm going to move the 20 over. That becomes negative 20, and I'll just divide out the negative here. And that gives me 20. So negative 10 and 20 are our zeros. But that does not necessarily answer the question. It's just a stepping stone to get to our answer. So let's think about it with a rough sketch of the quadratic in question. So So I'm just going to quickly label my graph. So all we know right now is that we have zeros or x-intercepts at -10 and 20, because this is our x-axis and this is our y-axis. But we're looking for maximum revenue, so what we actually need is the vertex of this quadratic. So let me write out my equation again. This should be a plus, this should be a minus. So we know our zeros are -10 and 20. If we want to find the x value for our vertex, which is going to give us our maximum, we would need to add our zeros together and divide by 2. So that is going to be -10 plus 20 is a +10 over 2, and finally a value of 5. So what that tells me is when x equals 5, that's when we have our vertex or our maximum. And now we just need to plug in that value for x, or in this case n, into our equation, because n is our independent variable. So let's do that. Ten times 5 is 50, plus 100 is going to be 150. 20 minus 5 is 15. And our final answer is $2,250. So when x equals 5, our maximum occurs at 2250. So I'm just going to draw a rough sketch of our quadratic here. So this is the maximum amount of money that Taylor Swift could make based on her current situation. Not too bad. But the second part of the question was, what if she only wants to make $2,000? So what I'm going to do is I'm going to set my quadratic equation equal to 2,000 and see when that happens. So what we're doing is I'm going to label this point right here as 2,000. What we're doing is we're basically raising the floor of our x-axis. And we're saying, okay, when I set the quadratic equal to this value, where are the 2 points that make that value true? So we've applied a value for our overall revenue. Now we just need to expand out our quadratic and solve. So we need to use the FOIL method to expand our brackets. So our first terms will give us 2,000. Outside terms is -100n. Inside terms 200n. And finally -n squared. But I need to set the left side to 0 because I want to get my quadratic working here. So 0 equals 2,000 minus 2,000, right? Because we moved this over and it's turned negative. So that'll cancel out. And then we have the rest of our terms. And here we can collect like terms. So we can simplify this even more. And I'm just going to put the -10n squared at the front, because that's what we usually do with quadratics. We'll put the term that is to the second degree at the front. So -100 plus 200 is plus 100n. So this is our new quadratic to solve. And immediately I can see that I can factor out a negative 10n from these two terms. And I'm left with an n minus 10. So what does that mean? Well, we've actually created a new factored form here. So I'm going to set both of my n values to 0. We have a negative 10n, and we have an n minus 10. Here, all I need to do is divide out my negative 10, and n equals 0. Here, I just need to move my negative 10 over, I get a positive 10. So what that tells me is when x equals 0 and when x equals 10 is when I get my revenue of $2,000. And what's interesting about n equaling 0 is that means that Taylor Swift doesn't even have to change the price of her shirts, because n represents the number of price changes. So if we don't do anything, she would make $2,000 selling her t-shirts for $20 a piece. However, if she wanted to be a little bit nicer, she could actually charge less and make the same amount, right? Let's look at that over here. If I have my original equation of 100 plus 10n, and I set the number of price changes to 10, I'm going to get 100 plus 100, and 20 minus 10 is 10. So in this scenario, she'd be selling 100 more t-shirts, right? Instead of selling 100, she's selling 200, and she's selling them half off. Instead of 20 bucks, we're down to 10. And she also makes $2,000. So if Taylor wanted to be nice to her fans, she could actually decrease the price of her shirt to $10 and make the same amount of money as if she hadn't made any changes. All right, so we helped Taylor out with that question. Now we're moving on to Beyonce. So Beyonce is doing renovations to her backyard. She wants to build a walkway of uniform width inside a patch of her garden. The garden measures 8 by 12 meters, and the area inside of the walkway must be 75% of the garden's area. Determine the width of the walkway. So I really like this question because A, it's very common on math tests, I find, and B, it kind of forces you to think outside the box of how to set up a question as a quadratic. So I want to do, right off the bat, is just draw a quick sketch. And since we're talking about a garden, let's do it in green. So, right off the bat, I know the garden measures 8 by 12 meters. I know that Beyonce wants a walkway, and the walkway is going to create a space in the middle that is 75% of the original area. But we want to determine what the width of the walkway should be. So we need to find an equation that's going to use the width of the walkway as a variable. So we know the walkway is of uniform width, so no matter where we are on the walkway, it has the same width. So I'm going to set that length as W. And let me think about representing the area in the inside of my garden with an equation. So I know that area is length times width. I need to think of how to represent this using the variable w. So let's look at this side first, kind of from here to here. I can see that the original garden is 12 meters, but inside of the garden, in this new area, it would actually be 12 minus 2 widths of the walkway, right? Because if I took 12 meters and I shaved off the walkway, I would have my new length. And I'm going to do the same for this side here. Originally, it was 8 meters, but if we subtract this width and this width, which is our walkway, we get our new length. So that will be 8 minus 2w. Okay, so far so good. But what about the value for area? Well, if we think about the original area, we would just have length times width, which is 8 times 12, and that is 96 meters squared. And the area inside of the walkway is going to be 75% of this area. So if I multiply 96 by 75%, I'm going to get 72 meters squared. So that's the value I'm going to put for my area. Now, it's very similar to our first question with Taylor. We just need to expand this quadratic out from factored form, move this value over here, and then solve for our zeros. So let's do that over here where we have some more space. Just going to rewrite that out. So first things first, let's expand. 12 times 8 is 96. 12 minus 2w is negative 24w. Negative 2w times 8 is negative 16w. And finally, negative 2w times negative 2w gives me 4w squared. Now we just need to move this over and collect our like terms. So 96 minus 72 minus 24w minus 16. So I have like terms here, I have like terms here, and just for good form, I want to put this term at the very front. So doing all of that, I get 4w squared minus 40w, and 96 minus 72 will give me 24. And I notice I can actually factor out 4 from all of my terms. So let's do that, make things a bit cleaner. All right, now we just need to get this into factored form. Normally what we would do with a simple trinomial like this is we're going to look for two numbers that multiply to give me 6 and add to give me negative 10. But I don't think there's any clean numbers that we can use for this. So we're actually going to go right into quadratic formula. So if at any point you're not really sure if you can factor something or not, you can always use the trusty quadratic formula. And we don't have to worry about the number that we factored out, we only have to think about our three terms in our trinomial. So this is our a value, this is our b value, and this is our c value. So I'm going to do that up here where I have a bit more space. I'm going to rewrite my quadratic formula with those numbers. So my b is a negative 10, and we're going to plus minus the square root of negative 10 squared minus 4. A value is 1, c value is 6. And that's going to be divided by 2, since our a value is 1. So these negatives cancel out. We get a positive 10 plus minus negative 10 squared is 100. 4 times 1 times 6 is 24 over 2. Now, because we have a plus minus sign here, that means that we're going to have two zeros, right? Because in one of the scenarios, we're going to add this square rooted number, and in one of the scenarios, we're going to subtract it. So for our first 0, we're going to do 10 plus square root of 100 minus 24, which should be 76 over 2. And if we plug that into our calculators, we should get 9.36 meters. For our second 0, we're going to want to subtract our square root, and that will give us an answer of 0.64 meters. So there we have it. Let's go back here. So our two possible widths are 9.36 or 0.64. Now, if you think about it, it can't be 9.36 meters, because if that were the case, the width of the walkway would be wider than the length of our original area, or this one of the sides of our original area. So that can't work. That means that the only one that works in a realistic sense is 0.64 meters. Therefore, the width of the walkway would be 64 centimeters, or 0.64 meters. So there you have it. Two real-life scenarios where it's very useful to create a quadratic, and both of them were in factored form, and then depending on the scenario, you will have to expand things out and go from there. So yeah, let's see everything we worked on today. I'm just going to zoom out quickly here. So yeah, we covered a lot, and hopefully that gives you a little bit more insight into how to work through these kinds of word problems, and good luck with your studying. Thanks for watching.